Hello, everyone. So the last talk before the lunch, actually. Related with cookies, but different kind of cookie. So hacking cookies in modern web applications and browsers. So let me first introduce myself briefly. I'm founder and CEO at Silesia Security Lab, a company that primarily is doing pen testing and advanced specialized security trainings, mainly offensive. What I love to do is hunting bugs. I found bugs in Google, Yahoo, Mozilla, Microsoft, Twitter, and so on and so forth. And what I do love to do, except being bank hunter and running a company and team of pen testers, is teach people. This is my true passion. My current training delivered here at HITBGSEC in Singapore and also other conferences around the world is like this: hacking web applications, case studies of award-winning bugs in Google, Yahoo, Mozilla, and more. So this is purely based on interesting bugs from these companies. Here's my mail and Twitter if you want to reach me out later. So let's go. Just a second. Oh, it works. Okay. So what's the motivation to prepare this talk? The main motivation is that cookies store sensitive data, and automatically, if it stores sensitive data like session ID, cross-site request forgery token, or anything else interesting and dependent on the app, that's why it is automatically interesting for attacker. That's the motivation number one. The point number two is that people very often focus on multi-factor authentication, and this is good. We know that if we have, let's say, 2 or 3-factor authentication, that this is really fine. But we have to think about the whole process. Security is as strong as the weakest point, and we all know about this. But we have to keep in mind that even if we have 3-factor authentication that is really strong, after successful authentication, the user is just recognized by the web server only by session ID or authentication cookie. If there's any kind of weakness in the lifecycle of authentication cookie, then the game is over, right? We can be impersonated by the attacker. So we have to take into account the whole life cycle, and this point is quite often missed by different people. When I do consulting, pen testing, then I see that are very much focused on multi-factor authentication, but forget about the whole life cycle. I will reference some problems later during this talk. Another one, what I have seen quite often is that cookie-related problems are really underestimated. If you, for example, if you report a problem to a customer or just see other pen testing reports, you see that the rating of risk is quite often low. I cannot agree, and I will show you that really cookie-related problem does not mean local exploitation, right? From CVSS point of view, we've got free access vectors local, adjacent network, or remote. In many cases, we can do exploitation of cookie problems remotely, and then automatically the risk is higher, more severe consequences, and so on and so forth. So this is yet another point why I want to give this talk. The next point is that those 3 here are more related to web app. Well, I love web app hacking, but let's say the whole system is like this: browser and web application, right? So we might also have problems with secure cookie processing on the browser level, and in fact we have. So it's very also good to talk about this perspective of cookie hacks, okay? And what about the consequences before going to details? The consequences of insecure cookie processing are, for example, user impersonation, authorization bypass, remote cookie tampering, and so on and so forth. So really bad things can happen if we don't take into account cookie processing seriously. Okay, so what's the agenda, basically? I will present cookie hacks will be presented from three perspectives. One, web application, the first one that comes up to our mind. The another is web browser level. I will show you a few problems right now in current browsers. And the last one is RFC 62665. We have to keep in mind that cookie processing is described in this document. This is just RFC that describes how cookies should be processed. And all modern browsers rely on this document. If you find any kind of weakness in this document, then the consequence is that all browsers are affected, right? That's why also it's very, very interesting from my point of view to dig into this document. So now I believe we have all perspectives. And of course, I have 1 hour. So I will present selected topics, but I believe that they are the most interesting ones. Okay, so let me start first from secure flag and HSTS. Something, let's say, we will have problems that are more interesting from development point of view, some problems from backhanding point of view, and some problems for people who are just interested in how browsers work, how should work, and so on and so forth. So secure flag. What's the reason? Let's starting from the basics. We use secure flags because we want to be sure that our cookie will never be disclosed over insecure HTTP. If this cookie has this flag, secure flag, then it will only be sent over secure HTTPS. That's the reason why we are using this flag, or why our authentication cookie or any other cookie actually should have this flag. But what's the problem? The problem is that well, this flag is used to protect the confidentiality so that it is not disclosed over insecure HTTP. But the big problem from RFC point of view is that insecure HTTP can overwrite a cookie with secure flag. So can you see the problem almost immediately? Insecure HTTP can have impact on security on secure HTTPS. So from design point of view, this is just wrong, and this is if you read this RFC, you will see that this attack scenario is possible. So insecure HTTP has impact on secure HTTPS. This is written in this RFC. Modern browsers rely on this RFC, so immediately all browsers are affected, or this problem, let's say, is in every browser. So here is another perspective of secure flag. When we do penetration testing, when we are strictly focused on web app, then this is the one that we know or should know. But this one is really interesting that something like this can be found in the RFC. Okay, so we use secure flag to protect the confidentiality, but it does. If we don't have secure flag, then it does not automatically mean that our cookie will be disclosed over insecure HTTP. What do I mean? You might have something like this, HSTS implemented, HTTP strict transport security. This is really powerful because it enforces HTTPS traffic from the browser's point of view. Very often people are focused on enforcement of HTTPS via a redirection on the server side. I mean, HTTP request goes on the server side, the response is 302, so redirection to HTTPS. But if you, of course, if you don't have secure flag, then your cookie leaks over insecure HTTP before redirection happens. This is really powerful because the browser knows that only secure HTTPS requests should be sent. Even if you manually try to type something in the URL, like HTTP, no, the browser will not allow you to do it. And from a configuration point of view, the overhead is extremely minimal because this is just one header in the response. If you have HSTS implemented and you don't have secure flag implemented, you are still secure, right? Because the HTTPS traffic is fully enforced. So this way of reasoning is fine, but there is one problem. HSTS, although this is very powerful, it is not supported by all major browsers. For example, Internet Explorer 10. Of course, the most up-to-date right now is Internet Explorer 11, but keep in mind, Internet Explorer 10 as an example. This is still fully supported version by Microsoft and used by quite many people. Just an example of modern browser currently supported by a vendor that does not support HSTS. So if you think that HSTS will solve your problem completely, no. Because if you only rely on HSTS and you don't have secure flag, then it means that in case of Internet Explorer 10, for example, the cookie will still leak over insecure HTTP. Okay? So the recommendation, just to cover all possible cases, independently on which browser is used by the user, is to use HSTS and secure flag. Of course, HSTS is, let's say, secure flag is just to secure the cookie. HSTS is more powerful also in terms of, well, it just secures or protects the whole request, but of course the request includes the cookie, and this talk is about cookie, so if I protect the whole request, I also protect the cookie. That's why I'm talking about this. But sometimes people claim that, yeah, we have HSTS, we are secure, we don't need secure flag. No, we do need, because this is not supported in all browsers. This is quite maybe surprising, but this is the reality. Of course, I always talk during this talk about the most up-to-date versions, right? Because otherwise it wouldn't have any sense. Okay, so let's go to another problem, importance of regeneration. And let's think about such case. User is logged out, so potentially nothing bad can happen, right? And the attacker is somehow able to learn a user's cookie with session ID. Of course, the attacker is always interested primarily in this cookie, because once the attacker is able to get it, then the consequence is user impersonation. Let's consider this case. So what's dangerous here? At the first glance, nothing, because user is logged out. So this is session ID. Actually, this is authentication cookie, but the user is not authenticated yet. So we may say, okay, I don't see any dangerous consequence here. But what might be the problem that quite often appears in web apps? The problem is that at this point, user is not authenticated. In a second, the user will log in to the app. But assume that something like this happened. User logs in, but session ID is not regenerated. In other words, the new value of session ID is not sent back to the user after successful authentication. I mean, lack of session regeneration, this is how it's called. And assume that something like this happened, so vulnerability in the life cycle of session cookie in this example. What's the consequence here? Here the consequence is user impersonation. So at the very beginning, we had something useless. I mean, attacker actually has something useless because user is not authenticated. But when we chain, for example, XSS, disclosure over insecure HTTP of this cookie, when the user is again logged out, if we chain it with a problem in the life cycle of authentication cookie, then finally we have user impersonation, because the session ID used by the user before being logged in and after successful authentication is the same, right? And it happens surprisingly in quite many places. So now we should know or remember that our cookies should be always regenerated after successful authentication, because we change the state from non-authenticated to the authenticated. That's why we should regenerate everything that is sensitive, not only cookie with session ID. Also CSRF token, persistent login token, and whatever else is sensitive from the perspective of our app, right? So it's really good to keep it in mind. Okay, let's discuss another problem that can happen. So the scenario right now is like this. User logs out, typical scenario, and the cookie with session ID is deleted in user's browser. And the question is user really logged out or not? Well, it might happen that the user seems to be logged out, but actually the user is not logged out. The fact that you see that cookie with session ID is deleted on the client side or in the browser does not mean that it was invalidated on the server side at the time of logging out, right? So when you log out, so what problem might happen? No server-side invalidation. It doesn't matter that the cookie was deleted on the client side. What matters is whether it was invalidated on the server side at the time of logging out. Because when this is the case, the user seems to be logged out, but actually, from the server point of view, it is still logged in. Just a second, okay. So the consequence, or the problem might be, well, the consequence of this is user impersonation, of course, under the assumption that the attacker was able somehow previously to read the session ID of the user when user was logged in. So user is logged in. We have a number of ways to extract session ID of the user, for example, via XSS, disclosure over insecure HTTP, and so on and so forth. But what's here interesting is that even if user is logged out, we can impersonate the user because we still have access to the user, although the user seems to be logged out, right? Because there was no server-side invalidation. Okay, let's go to another topic, HTTP-only flag. What's the reason or what's the logic behind this flag? Let's say the most classical attack scenario when XSS attack occurs is that the attacker wants to just extract the value of, for example, session cookie, because then the attacker does not have to do anything, just take the value, put to the cookie jar of the attacker, and impersonate the user. The game is over. That's why HTTP-only flag was introduced in the past, so that when XSS attack occurs, JavaScript cannot read a cookie with HTTP-only flag. That's the reason. In general, non-HTTP API cannot read a cookie with HTTP-only flag. That's the reason of introducing this. But what's the problem? Again, I'm primarily focused on web apps because that's what I do for a living. But as I mentioned at the beginning, I always want to read RFC 6265, the most up-to-date, just to see if there are any problems or potential problems. And what's interesting is that access permissions are not clearly specified in this RFC. Keep in mind that this RFC is supported by all browsers. What do I mean by access permission not clearly specified? The point about this HTTP-only flag or the restriction is that non-HTTP API, well, the point is, as written here, JavaScript cannot read this cookie. So this is about reading. It says clearly that it cannot read. The point is, okay, we cannot read, so reading restriction. What about overwriting? This is the question. And this is what I mean, but access permissions are not clearly specified. I read the RFC and see something explicitly said about reading, but what about writing? And as we can know, if writing is not specified, well, we see immediately ambiguity. And ambiguity is really just an enemy of security. We also know about this. So the point is how different browsers handle this problem, right? How this is processed. Because ambiguity is really nice from backhunter's point of view or just from attacker's point of view. And it turns out that in Safari 8, the most up-to-date one, cookie with HTTP-only flag can be overwritten. So the core of the problem was ambiguity in the RFC. What about some attack scenarios? What's the point? We need to figure out some potentially interesting attack scenario. What's the point of overwriting a cookie with HTTP-only flag? So that if there is no profit, there is no point of talking about this, right? So now, again, assume that XSS attack occurred. We cannot read a cookie with this flag, but we can override this cookie. So what we can do, if we can override a cookie with HTTP-only flag, then we can switch a user to attacker's account. It may sound like something strange, because what for? But one of the attack scenarios might be like this. I switch a user to my account. Let's assume that I am an attacker. In the profile, I have credit card form. And it may happen that the user will not notice that the user has been switched. And actually, a credit card data of the user is entered to my account, right? The profit is obvious. So credit card data of the user lands in my account. So we have some attack scenario that is interesting. But this is not the only one, attack scenario. The another one, more interesting, is user impersonation. Keep in mind one of the previous problems that I have discussed, related with no session regeneration when we go from non-authenticated to authenticated state. So what's going to happen right now? So as you can see, I connect different problems, small problems. And this is what I really love, because those small problems sometimes on their own are meaningless, but when I connect them, I have something powerful. So again, let's assume that XSS attack occurs. I overwrite session ID of the user, or actually cookie with session ID, to some arbitrary value. The user, some arbitrary value, I mean, at the time of overwriting, this value is not recognized by the server. So user is locked out. But now, when user is locked out, user does not know what has happened. User logs in again. So, but I overwrote this cookie with a value of my own choice, right? I know this value. After successful authentication, this value will not be changed because there was no session ID regeneration after successful login. User is finally logged in, and I am finally, as attacker, very, very happy because I know user's session ID. So connecting these dots is beautiful, and the reason why I do what I do, actually. So you can see that we started from RFC and ambiguity, and we figure out something interesting. I believe not only interesting for me, also for you. So let's discuss another problem. We've got also something like domain attribute. When we specify a cookie, if you take a look, well, from the perspective of response header, right? We have set cookie. This cookie might have secure flag, HTTP-only flag, but also domain might be specified. It's not obligatory to specify the domain, but it may be specified. And if you go again to this RFC, you can see something like this, that when this domain attribute is not specified, then cookie will be sent only to domain from which it originated. On the other hand, and this is a very popular solution, when you see that the domain attribute, for example, is abc.com, then this cookie will be sent to abc.com and all subdomains of abc.com, but provided that domain attribute is specified. If this is not specified, it will only be sent to the domain from which it originated. Well, the logic behind this is you don't want your cookie, sensitive cookie, to be disclosed to other subdomains, right? So this is logical why it was introduced to this RFC. But the question is, as always, are there any problems with this? The answer is yes, there are. In Internet Explorer 11, again, the most up-to-date, Well, actually, Internet Explorer 11 just ignores it. I mean, again, if this cookie is not specified, then you only should send this cookie as a browser to the domain from which it originated. But Internet Explorer 11 will send it also to all subdomains of this domain. So it is completely not taken into account by Internet Explorer. So even if we are skilled developers and we have read very carefully RFC, and we feel that we know how to do it securely, well, Internet Explorer 11 will not help you in this case. So keep it in mind. What about attack scenarios? As always, we want to discuss some attack scenarios because that's always the most interesting part. So let's have a case like this. Let's say that example.com wallet, this is very sensitive app is out there, okay? Keep in mind that the domain itself is example.com. This is sensitive, and we can assume the sensitive, it was very thoroughly analyzed from security point of view. On the other hand, we have something insensitive, and it happens in many companies, that a subdomain, like here, x.example.com, is insensitive, this is meaningless, so probable assumption is that you can find something interesting out there, right? From probability point of view. If something is not sensitive, then very probably it hasn't been thoroughly analyzed from security point of view. That's why, as a bug hunter, I always interested in something like this, because I know that when I find XSS on this, then if there is XSS on xexample.com, I can set an arbitrary cookie to the main domain that will be sent to the main domain and all subdomains, right? So if I have XSS on this one, I can set a cookie from that will be sent to this domain and all other subdomains. In general, this is how it works. But coming back to our case, here developer was very smart, very educated, and read the RFC. And in this case, just example.com wallet, the developer did not specify this domain attribute. So now the developer is almost sure that this cookie here for example.com cannot be accessed by subdomains, right? Because this was the reason why the developer didn't use domain attribute, okay? But the problem is that in case of Internet Explorer 11, as I mentioned, this is completely not taken into account. I mean this, how cookies should be processed when domain attribute is not specified. So in this case, if we have XSS on xexample.com, it will be able to read a cookie that should be limited only to example.com, because Internet Explorer 11 will allow it to be sent due to this problem, because it does not support this part of the RFC, okay? So just to conclude, this was sensitive, and normally, if it would work fine, then XSS on subdomain would not be able to get this cookie, because there was no domain attribute specified. But because this is not supported or just not taken into account by Internet Explorer, it will be sent to other insensitive subdomains, and here is a very realistic attack scenario. Another attack scenario is, for example, cookie leakage to externally managed domain. Just to continue a little bit longer this example, it might happen that example.com right now is the hosting company, and you could buy a subdomain. So we've got shared hosting. So right now, x.example.com is a shared, we've got shared hosting, so you can go as a client and buy X, for example, example.com. Then you don't need any kind of XSS. You just control x.example.com, and you have direct access to example.com/clients, for example. And those guys who developed example.com/clients, they think, okay, we don't have domain attributes, so any other subdomain cannot get a cookie that allows to get access to our own management platform from our clients. It's wrong, because again, in case of Internet Explorer 11, it will just we will be able to do it. And again, in this example, we don't need any kind of XSS. Okay, so let's go to another problem. Cookie tampering. It turns out that in Safari 8, you can, well, actually, Safari 8 supports a comma-separated list of cookies. So comma-separated, you've got in a set cookie header. So you've got set cookie, name, and value, but you can specify comma and then another name and another value of the cookie. So you can specify multiple cookies. You see right there that in the round brackets, obsoleted RFC 2109. It is obsoleted because the most up-to-date one is, as I mentioned previously, 6265, RFC 6265. But the fact that RFC like 2109 is obsoleted, it does not automatically mean that obsoleted features of obsoleted RFC are not supported in the most up-to-date versions of browsers, right? We know it, this is reality. Obsoleted does not mean that it will not be supported by most up-to-date versions. So that's why I always love to go one step back in the history and see if something risky was really risky from the previous RFC was deleted by vendors in the, when a problem was detected. I mean, you can see a risky part in the RFC 2109. Delete this part in the most up-to-date RFC 6265, and this is actually the case here. That those guys noticed that, well, something like this is risky. That they deleted it from the most up-to-date version of RFC, but Safari still supports this risky feature. And it looks like this. This is part of the URL. You've got something like this in the URL. You've got language equals DE for German, for example, then comma %20, so URL encoded space character, and then the cookie of your own choice, right? For example, PHP says ID that equals ABC. Of course, the assumption is that this is reflected in set cookie header. Keep in mind, right? Because we are talking about set cookie header in response. So what's the consequence? The attacker via this obsoleted, this comma-supported list of cookies in set cookie header from obsoleted RFC 2109 is supported in Safari. So if we have, of course, the prerequisite is that there is no cross-site request for zero token, right? Otherwise, we cannot launch this attack cross-origin. But in general, we ask the victim to click a link like this was. Of course, we don't have the domain here, but for the purpose of understanding, it's not needed. The victim just clicks this link, and we are able to overwrite a value of arbitrary cookie in a cookie jar of the user. And this is very, very powerful. We already see that we can do remote cookie tampering. What about attack scenarios? Switching a user to another's account, we have already discussed it. We've got also user impersonation. When we chain it with yet another problem like lack of session regeneration, also discussed previously. And we can remotely launch XSS via cookie. Sometimes we really do need something like this because, well, XSS via cookie with the only attack vector like local exploitation, this is not powerful, right? Because it assumes that we have access to the cookie jar of the user, so the risk is much, much lower. But right now, if we use this technique, we can fully remotely set arbitrary cookie, and now without any limitations, launch remotely accesses via cookie. I will tell you more about remote accesses via cookie exploitation, because this is one of the most underestimated problems in general that I see from my experience. So the next slide will be dedicated to this problem. But before we go to this, this is just an example that shows this is what I love, and I see some students from my from my training, and the most interesting point from their point of view in the feedback, and it happens always at different cons, is that they love to chain different problems and see how browser-specific bugs can be used to launch much more powerful attacks. And this is just an example related to cookie. I have, of course, more of them in my training. But this is really powerful. Keep it in mind, because sometimes you can just have something much more powerful. If you participate in bug bounty programs, you can definitely get more money for this. If you want to impress your clients and make the CVSS score higher, then this is the right direction, right? So keep it in mind about this, dependently on what you do. So now, underestimated accesses via cookie, very often this is associated with local exploitation. But this is absolutely not true, because I will present you 3 remote attack scenarios just to show that this is not true, and this is what I would like you to keep in mind. So now assume similar example, but a bit different. We've got sensitive domain yexample.com and insensitive xexample.com. What is common is example.com. There are both subdomains of example.com. And now you are doing pen testing, and you have found accesses via cookie on sensitive domain, and you are very happy. And this is obvious why you are very happy, but the question is how to launch this attack remotely. This is very often the case, and very often if managers see that accesses via cookie is possible, then on Jira you can see the risk as low, and very often it is just like that forever. But what you can do is, again, try to dig into another subdomain, less sensitive one. If you find XSS on this subdomain like x.example.com, you can set, because this is how cookies work. This is different than same origin policy from JavaScript point of view, right? Same origin policy, if you have XSS, is like this. I can work here within the, let's say, context of domain xexample.com. Let's say the protocol is HTTPS and port 443. This is same origin policy from XSS point of view. But from the point of view of cookie processing, XSS on this domain, xexample.com, can set a cookie that will be sent to this, let's say, core domain and all other subdomains. So can you see it right now? We are on xexample.com. We set a cookie that will be sent for the domain example.com and all subdomains, so including sensitive yexample.com. So if we find some XSS on something insensitive, we can launch via this XSS remotely XSS via cookie on sensitive subdomain. Quite nice combination of things, and it is really also helpful in practice. So this is one way of doing it completely remotely. And don't focus only on your target here. Your target is like this, but there might be many interesting insensitive things on other subdomains. Another attack scenario. Let's assume that in this example, the triggering point, let's say, was not XSS, but response splitting attack. In case of response splitting attack, you use special characters like carriage return and new line to split the headers and escape from headers to the body. And once you do response splitting, the consequence of response splitting might be XSS, and then the story is exactly the same, but the triggering factor might be response splitting. So via response splitting, you launch XSS, and via this XSS, you launch XSS via cookie fully remotely. The way of reasoning is just the same, because response splitting can be used to launch XSS, and then use this point. And yet another one from the previous slide. I have presented how you can use cookie tampering in Safari 8 just to fully remotely set an arbitrary cookie in the cookie jar of the user. So in this case, you don't need any kind of insensitive subdomain. Just do it. Send the link, for example, and this is it. And you've got fully working remote solutions. So now we see that we really should take care of this, and what I love here is that we really connect different pieces and have something meaningful at the end. So I would like to emphasize that even if we see something small and we cannot exploit it directly, we can connect it in different cases, in different problems, to have something powerful at the end. Okay, so let me make some conclusions. By the way, everything that I tried to let's say teach you during this talk is written in the white paper, so feel free to read it step by step. If something was not clear, if it is still not clear, so just send me an email. So what are the conclusions? So what we should do independently, whether we are researchers, engineers, consultants, whatever, just security people, educate development teams. This is very important. And I do believe that this is important. I very often see that security people blame developers. No, we should blame ourselves. This is my responsibility to help people to understand how to do something securely. The developer has many, many other duties and skills that I don't have. This is my goal, to teach people how to do something securely. And we should do it. This is our job. I'm not saying this because I love doing trainings and so on and so forth. This is just how it should work. This is part of the whole process. Then another point. So if we do the first one, educate development teams, then we will see finally less problems on the web application level. But what about the browser level? Well, we need to cooperate with our browser vendors, and browser vendors should cooperate with us, because sometimes from, let's say, practical point of view, time of response is very long, and those issues are not taken into account very seriously, and so on and so forth. The reason why they are not sometimes taken seriously by vendors is that this is what I got in the response. When I was submitting different bugs, is that on their own, in many cases, they don't allow us to do exploitation, right? If you've got something like remotely executable classical RCE on, let's say, Safari, then definitely the vendor will be interested. But when you have a kind of small vulnerability, then the developer quite often will tell you, okay, but it requires additional vulnerabilities, so this is not actually the vulnerability in my browser X, so we are not going to fix it. Okay, their point of view, but from my point of view as a bug hunter, I connect small dots and have something very powerful. So I partially understand their way of reasoning, because it requires other vulnerabilities in the app, so they blame the developers. But I don't care, I just have to connect different problems to have something very powerful at the end. And finally, the foundation for cookie processing is RFC 6265, as I mentioned. So we all need to think about some improvements, discuss these documents, discuss some problems, improvements, and so on and so forth, because well, we all rely on this document, so this is in our interest, right? So basically, this is it. Thank you very much for attention. I know everyone is hungry, but now it's time to ask questions. If you want, I will be available also around, so don't hesitate to ask me about anything. Any questions right now before the lunch?
Any questions from the floor?
Anyone?
Or reserve the questions for when Dawid's off stage during lunch, maybe? Yeah?
Okay.
All right.
We've got more than 1 hour for questions during the lunch, so I am happy to answer your questions. Thank you very much for your attention, and see you later.
Thank you very much.